Okay, Andy, what we're going to do here is I'm going to show you how to create these profiles. In a sense, you don't have to create them. They're already created, but they have to be edited to match the data that you get, that you measure at the house that you're doing. But let me show you what this page looks like first. It may help you understand this. This line across here is, in essence, this is a frame. It consists of this line and this inner border here also. All this is part of a frame. You can think of that as a container that holds certain things. It holds a chart, which is what this is. Okay. It also holds, this is like a calculation spreadsheet object, might be the best way to describe it. And it holds this, which is basically, if I remember right, just a text box. In fact, you can click in here and then you can edit. You can also click this, double click it, and you can edit this. You can edit, that's the span. You can edit here is the deflection, and the deflection ratio is calculated for you, and normally this will just say nil, and there's usually no reason to change that. You can see it says sheet 1. This is actually a calculation sheet from a spreadsheet that's created. It operates within the Writer program. So that's what's here, and now we're going to show you how to use the data that you would put here to create or edit this file. So all I'm going to do is put my cursor inside the chart and double click it, and you notice my red line that had the arrows on it went away, and it says chart below the cursor here. And so I'm going to right click it now, and it says chart data table. So I click that, and here's my data table. And these X values, like if we're middle transverse, the first one at the front is at 0. The last one is at the end of the profile, and that's whatever you measure your span to be. In this case, it was 22 feet. But if you're doing one, and let's say it needs to be 30 feet, you just click that and stick 30 in there. And then you always click the middle one and you make it halfway. So in this case, it would be 15. These are your elevation values that you edited or that you measured. And let's just say the first one was 0. And the second one was, let's just say, 0.4. And the third one was minus 0.2. Okay, so that's fine. So we just click X and we come out of it, and now you'll notice that the curve doesn't really fit on in the graph very well, and that's because we haven't adjusted the domain. So while we still have this green thing to show that that's selected, we come over here and you'll see it says Y-axis. Okay, so when you get that Y-axis, you right click. Yeah, I got off of it. Do it again, right click it, and the first thing says format axis. So we format it. Okay, and this gives us our minimum and maximum, which I don't remember what they were now. I think the minimum was minus 0.2, so we'll make this minus 0.3. We want to go 1/10 below. And the maximum I think was 0.4, so we'll make the maximum 0.5. Again, that's 1/10 of an inch above the maximum, and this one below, or the minimum, was 1/10 of an inch below. So we're bracketing our data. Is the way to think of it. And when you have that done, you just click X, and it didn't change that. So let's go back and figure out what we did wrong here. I bet you I shouldn't have clicked X. Let's see. Yeah, see, I should have clicked OK. So let's go back, and again, we think our minimum was minus 0.2, so we'll make this minus 0.3, and our maximum was 0.4, so we'll make this 0.5. And now instead of clicking X, we just click OK. And now you see it's redrawn it within that domain. There's our 0.5. Here's our minus 0.3. We're 1/10 of an inch below the minimum and 1/10 of an inch above the maximum, which is what we want it to be. So we just come outside again over here and double click it to deselect everything, and now we have everything here. The only thing we need to do is click on the arrow here and then move that to this end. Come over here on this end, move that up, And now we look at, we're at 0.4 here and we're at minus 0.1 here. So that's 0.5 inches in difference. Don't worry about the plus or minus. It's just if we measure from here to here, it's going to be a ½ inch. So we come to our first graph and we click in here and we say, okay, it's 0.5. And I don't remember what the span was. Let's say it was 30. And then that's all we do. We just click off of it, and now we have a deflection ratio of 0.5 over 360 with very little tilt. In here, all we're going to do is say, is it a center lift with tilt or an edge lift with tilt? Well, since this is an upside down bowl shape, it's center lift, and it tilted. So, and I wouldn't call this very high. This is normal, so I would just say it's moderate. And leave the rest of it alone. It's moderate center lift. So that does that. And you just click off of it, you're out of it, you're done. That's all there is to it. You just go to the next one. Again, we come in here, double click it, we're in the chart, right click, chart data, we put our data in here, and then we close it, okay, and we're fine, and we come to our x-axis, and we right click, format axis, and we make sure we're on scale. And so we make, again, our minimum, and make it 1/10 of an inch less. Our maximum, we make it 1/10 of an inch more than the numbers, the measurements. And we click OK, and we click back over here, and then we move the arrows around and read off the deflection. And that's it. There's really nothing more to it. It's basically all the calculations are automatic. So we'll end this at this point and make this video.